Hello, I'm Edward Tart, math teacher. This is one in a series of solution videos to some of my math challenges. This one is about positive rational numbers. Here is my presentation of that challenge in the original video. This video is about two kinds of numbers. First, counting numbers. They are numbers by which we can count objects. 1, 2, 3, 4, 5, 6, 7, and so on indefinitely. Secondly, another category of numbers, a positive rational number is a number that can be expressed as a fraction with a counting number on top and a counting number on the bottom. And so, for example, 3/4 is a positive rational number. 1½ is a positive rational number because it can be expressed as 3/2, meaning 3 divided by 2. Neither of those numbers, neither 3/4 nor 1½ is a counting number. 7 is an example of both. 7 is a counting number. It can also be classified as a positive rational number because it can be expressed as 7/1, meaning 7 divided by 1. Concerning counting numbers, we can show them neatly on a number line, 1 unit apart as we move along from left to right indefinitely. If I would mark other positive rational numbers on the number line, that number line would soon become very congested. In math, we have lists of numbers, also called sequences. Some sequences stop, others go on indefinitely. For example, a sequence of counting numbers from 1 through 10 stops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's it. We can also form a sequence of all counting numbers. Such a sequence goes on indefinitely. It can be like this: 1, 2, 3, 4, 5, 6, 7, and so on indefinitely, adding 1 each time. I cannot write that entire sequence, it would take forever. But since I have just described that sequence accurately, we say in math that it exists. There exists a sequence of all counting numbers. And now here is your challenge. Does there exist a sequence of all positive rational numbers? If your answer is no, why is that? If your answer is yes, prove it by giving an accurate description of such a sequence. Well, I got a bunch of respondents. The vast majority of respondents said the answer is no, that it is impossible to have a list of all positive rational numbers. But that is incorrect. The answer is yes, such a list does exist, and I will now show you an example of such a list. We will start with the one counting number, the one positive rational number whose numerator and denominator add up to 2. After that, we will put the positive rational numbers whose numerator and denominator add up to 3. There are 2 of those. Followed by all the positive rational numbers whose numerator and denominator add up to 4. There are 3 of those. Followed by all of them whose numerator and denominator add up to 5. There are 4 of those. After that, we will put all of them whose numerator and denominator add up to 6, 5 of those.
then that add up to 7, then that add up to 8, and so on indefinitely. As we go along, we could cross out duplicates. For example, we could cross out 2 over 2 because it has the same value as the earlier 1 over 1, namely the number 1. And thus we will have a complete list of all positive rational numbers. They do not form a list in order from left to right on a number line. That is not possible. But I did not specify in my challenge that it necessarily needed to be that way. So that's my solution to my positive rational numbers challenge. I invite you to visit my profile page, the Math Videos playlist, and browse that collection and perhaps find one that you haven't yet seen. I have a wide variety of what I think are very interesting math videos. Thank you for watching this video.